All right, so when we want to differentiate functions, not all the functions are straightforward, and we can use the table of derivatives to find the derivative of the function. So let's go back and say we had y equals the square root of x. Now that's a pretty straightforward one to find the derivative of. We make the square root of x into a fractional power, and we know that the square root is the same as to the power of a half, just like the cubed root would be the power of 1 over 3. And to find dy dx, we just use our table of values. So dy dx is equal to, we bring the half down, x, and we take 1 off the power. So that's a half minus 1. And we get 1 over 2 x to the negative a half. And we know also that to the negative a half, you can take it downstairs and make it to the positive. And when we multiply out the top, we get 1 over 2. Now instead of to the power of a half, we can go back and use the radical sign. So it's 1 over 2 root x. Okay, so that's just using our table of derivatives that we know. What happens if underneath the square root sign we have something a bit more than x? So if we had y equals the square root of 3x squared plus 5x. Okay, now that's a little bit more complicated because it's a bit like what we were doing with composite functions before. We've got a function here of 3x squared plus 5x, and then we've got another function, square root. So what we need to do is apply another rule, and this is called the chain rule. If I gave you a value of x and I said, what's the value of y? What you'd do is actually calculate the value of 3x squared plus 5x, what I've circled here in red. You'd actually do that first and then find the square root of the answer after you did that. So in some ways the chain rule sort of goes along with that, and the fact that we let u being another function of x, being the first function that you would calculate. In this case it would be 3x squared plus 5x. So we'll let u equals 3x squared plus 5x, and then we can say that du dx is equal to, just apply our rule, so that'll be 6x plus 5. But now what we can do is, because u is equal to that, we can make y equals the square root of u. So we've done a substitution, and what that allows us to do, we can say go back and u to the half. So we can say that dy du now, if we find the derivative of this with respect to u, we get a half u to the minus a half, or as we've found out up here, it'll be 1 over twice the square root of u. Okay, so by making the substitution, letting u equal the first thing we would calculate if you were given a value of x and asked to find the value of that function, that's the key to find which function we're going to substitute for u. And in this case, it's the first one you calculate. So 3x squared plus 5x here is u, du dx, and then we can simplify our function y equals that, and so on. So then we get dy dx, and this is the chain rule. Dy dx equals dy du times du dx. Now that's the chain rule. It says that dy dx is dy du times du dx. If you like, you can remember it by thinking that, okay, if we were to cancel that du with that du, we've got dy dx is equal to dy dx. But as you know, dy du is an entity in itself, and so is du dx. Now we do the substitution in. So what was dy du was 1 over twice the square root of u times du dx from up here is 6x plus 5. Maybe a good idea to put that in brackets so we don't multiply by the 6x and forget about the 5. Okay, now our original, we were asked to find dy dx, so better write the question up here, find dy dx. And we're expecting an answer just purely in terms of x, not we introduced this u. The u wasn't in the original question, so we have to do a back substitution and go and back substitute for this u down here. So that'll be 1 over twice the square root. Now that u was 3x squared plus 5x. Make sure the square root sign goes over the top of it. And it's times 6x plus 5. Now the 6x plus 5 can be just multiplied by the 1 here, and we get 6x plus 5. Okay, now just as a little side thing, you know you can't cancel that 2 and that 6 because this has not been fully factorised. If we could factorise, if that was a 4 there and we could take a 2 out the front, then we could cancel because that 2 is connected to all of that by multiply. This 6 is only connected to the x by multiply, then we've got a plus 5. So we can't cancel that 2 and that 6. So that's our answer. That is dy dx if y equals the square root of 3x squared plus 5x. Now the key things to look at is that we use the chain rule when you get a function of a function, and you know that that's like h of g of x. In this case, my g of x was equal to 3x squared plus 5x, and h of x would be like the square root of x. All right, so when you do h of g of x, we actually in there, we substitute in the 3x squared plus 5x. And that's what gives us this function of y here. So make the substitution, identify u and simplify what y is, and then go through and apply the chain rule, dy dx, dy du, du dx, and then do the substitution, and don't forget to do the back substitution in the end. A quick one, let's do another one. So we've got y equals 6e to the 4x squared minus 1. Okay, so what are we going to make u equal to? Now, once again, if I was to ask you to calculate this given x equals 3, what would you do first? You'd put x equals 3 up here, and you'd square it times 4, and then take 1. So that will be my u. So we let u equals 4x squared take 1. So du dx, 2 times 4, 8x, take 1 off the power, and we get x to the 1, minus, and the square root of constant is 0, so it's just equal to 8x. And then we've got, where did that line come from? Then we've got y equals 6e to the u. So dy du equals d du of 6e to the u. Now, a constant multiply out the front can come out the front, so that's 6 d du of e to the u, and we know that the derivative with respect to x of e to the x is e to the x, so the derivative with respect to u of e to the u will be e to the u, so that's 6e to the u. So chain rule, dy dx equals dy du times du dx. And dy du is 6e to the u times du dx is 8x. Now it is common to bring something like 8x to the front, and we can go 6 times 8 which is 48x e to the u, but the u is 4x squared minus 1. So we've got to give our final answer all in terms of x, not in u, because we're the ones that introduced the u, just so we could use the chain rule and do the derivative. Okay, so that's the chain rule. The hardest thing with all these is identifying what you're going to let u equal to, but if you just think of function of a function, which one would you calculate first? Well, that's what you make u equal to, and then it should be a matter of just applying the rule.